So, section 8.3, claims about a mean. Process is identical to 8.2. Some of the players look a little different, but the process remains entirely the same. So let's run through everything in that regard. The goal, we want to test claims about a population mean. And we will use X bar for tests on, or I guess about, mu, using all the fancy symbols. And again, that little picture holds. We've got the big unknown population with an unknown mean mu. We've got a very small sample, but we know a lot about that sample. Excuse me. And we want to be able to extrapolate. So that's the same. Before I get into the detail, let me get the requirements out of the way. These requirements, compared to the requirements for a test about a proportion in the previous section, are really quite checkable. And I'll be honest, I will ask students to check requirements on quizzes and on exams. So for claims about a mean, we need one, a simple random sample. As this goes on and on and on and on and on, you'll note that this is always the first requirement, simple random sample. And then either one, the other, or both, n greater than 30, a normal distribution on the variable of interest. You just need one of them. If both of them happen, that's fine. The gold standard, honestly, is trying to make sure your sample is greater than 30. If it's greater than 30, then you've got nothing to worry about. You're fully justified in using all the wonderful tools. We have a test statistic. And I do ask students, again, to find the test statistic. This is T equals X bar minus mu all over S divided by the square root of A. And you'll notice again that it's a mix of detail from the sample data. We've got sample data stuff right here. And we've got claim data stuff right here. You'll also note that this guy works with the T distribution. The text actually talks about the Z distribution if you have access to the population standard deviation, but we just do not cover that material because that is really a very unlikely situation. Kind of a throwback, actually, when it was a little bit easier, or before everyone had calculators, honestly. So that's our test statistic. In general, we use the TI84 Tool t-test. Oh, and by the way, I meant to mention this on the other previous sheet. The requirements for this test are exactly the same requirements we had when constructing a confidence interval for a population mean back in 7.2. So there's a lot of overlap there. So we're going to use the TI84 tool t-test, and we're going to use it with the p-value method. So what I really need to do is to run through the examples here. I'm going to give you 2 examples. That's because there is one little detail here that's a bit different than in the previous section. So the p-value method, and our TI tool can use summary statistics, summary stats, that's the X bar, the S, and the N, or it can use raw sample data. So you can go directly from numbers in a sample right to through to the test. I'm going to do the basic one first, and then I'll run through one with the sample data. The sample data usually is a little bit wordy for, well, I'll explain why when we get there. So here's a claim. Claim, mean commute time is more than 40 minutes. All right, we're going to use, for this claim, we're going to use an alpha of 5%. And I've got to make up some data here. So let's see. X bar equals 47 minutes. S equals, let's make it really straightforward, 3 minutes. And N is equal to 32. Oh, no, make it 132. I want to reject the null hypothesis, and that'll help. It's really weird if you play around with this. Well, I'll stop. Hold on. Let me not get ahead of myself. So there's my claim. A lot of this looks exactly like this in 8.3. And if you're not careful, you might get a little bit confused about where to go. So you got to note that this claim is about a mean. So remember, these are going to appear with problems from all through this chapter. So this should be able to direct you to the material in 8.3. What do we know about the mean? For the claim, we know that it is more than 40 minutes. So what we want to be able to do is to take that claim about a mean, mu, and translate it into some kind of symbolic statement. The mean, mu, is greater than 40 minutes. So you can see here that now I've got that translated. I can see what I'm working with. I see that I've got a strict inequality, so we're working with the alternative hypothesis. So if the alternative hypothesis is the mean is greater than 40 minutes, the complementary hypothesis, written with just an equals, the complement to that is less than or equal to, but we always just write the equals. So there's our convention. Now we're all ready to go. I need my data. I need this guy here, and I'll need him here eventually to compare to my p-value, or to compare to my test, the p-value. So let me get this out of the way, and I'll run through the 5 steps. And again, it's always the same. H0, the mean equals 40 minutes. H1, the mean is greater than 40 minutes. My initial claim is the alternative hypothesis. I'm now ready to find my p-value and compare it to alpha. This is where I'll just jump right over to the calculator and take care of that. Let's see. There we go. All right. So stat over to test, t-test, And this is where I need to make sure I'm working in the correct mode. I don't have data, I have summary statistics. And usually you can tell because I just got done writing X bar S and N. We've got our null hypothesis of 40 minutes. The mean sample time was 47 minutes. The standard deviation was 3 minutes. And the sample size was 132, well above the 30 one that we require. So go ahead and hit calculate. Ooh, take a look at that p-value. That's ridiculous. So, oh, look at that. I can also tell I got a bit of a typo. One of the nice things about this particular type of test, it's not going to really, this will change here. You'll see how it changes in just a bit. I can see here that I've got the wrong alternative hypothesis. It needs to be a right tail test. There we go. So negative 55 was the exponent on the 10. Still negative 55. This is about twice what it was. All right, so there's my p-value, 2.47 times 10 to the negative 55. Let me stop my sharing. By the way, look at that t-value. Look how far away it is from 0. 40 and 47 are way, way far apart with a standard deviation of 3 and a sample size of 132. This is already 2 standard deviations, more than 2 standard deviations away in terms of that weird rule of thumb we use sometimes. So there's my p-value. 2.47 times 10 to the negative 55. 0.05 was my level of significance. So we are going to go ahead and reject our null hypothesis. That means we're going with the alternative. So at get my alpha in there, and alpha equals 5%. Data support mu is greater than 40 minutes. There we go. And we have the 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So hopefully people will be able to take care of this type of problem on this type of question. This is a hard one to sort of work into the testing paradigm we use. I usually ask people to pull out various pieces of the test. If I ask you to do the test, I'll ask you like 3 or 4 different questions. What's the p-value? Do we reject? Is the initial claim supported? Whatever it might be, but it will be very directed. You should be able to answer it if you can run through the 5 steps. So that's a fairly common example. By the way, that is where we take that decimal and we move it 55 places all the way over here. This is like a really tiny number. And this is what I thought happened at that first question that we ran into. All right, so let me go ahead and switch gears and work with a problem. This one will be probably even worse because I really have to make up numbers here. But I always like to see what I get, so it's kind of fun. It's also much harder to develop intuition about where answers go when you make little changes in problems. I've gotten fairly good at it, but in stats, it's a challenge. It's not like algebra. It's like if I change this a little bit, that'll change a lot. It's pretty straightforward. So, raw data. So, as I say, we can work directly with samples. And if they are small, i.e. n less than or equal to 30, below that magic number of 31, the population must follow a normal distribution over whatever the variable is we are investigating. And this is not like a got you or anything, because when we ask you these problems, we're not trying to set you up for failure. In other words, we'll say, well, you'll see in my example, we tell you exactly what's going on. By the way, if it is not normal and it is small, there are advanced statistical tools that we can use. So it's not like we just like go home and don't play. There's some really advanced tools that we can use. So let's see. Thanksgiving's on the way, so I wonder what the average turkey weighs. Anyway, I've gone out and I've got myself a sample of n equals 12, and we've got the weights in pounds. So let's go 16, 12, 18, 17, 19, 22, 1, 2, 3, 4, 5, 6, 25, 25, 21, 29. Ooh, big guy there. 20, and I don't know, 15. So we've got 12 scores, and we're going to assume weight follows a normal distribution. And we're going to test the claim. And the claim is that the weight is, oh, let me be a little bit more precise. Mean weight is less than 20 pounds. And we're going to use alpha. I'll use a 5%. I have no idea where this is going to go. Really depends on my sample mean and the standard deviation. It's a small sample, 12. So we're only going to be able to reject the null hypothesis probably if there's really quite a deviation from the 20. So there's my detail. Let me go ahead and get everything I need going, and then I'll go ahead and put the data in my calculator. Well, actually, no, let me put the data in my calculator first. Then I'll jump back here and we'll switch sheets. Edit. I'm going to use list 1. And we've got 16, 12, and 18. And we got 17, 19, and 22. We have 25, 25, and 21. We have 29, 20, and 25, 15. You know what? I'm going to change my problem a little bit. I'm going to change it to more than 20 pounds. All right, so there's my data. It's in list 1. Stat. Now, I'm not going to do any button pushing just yet. I'm going to note that I will be working with data. All right, so let me stop my sharing. Come back over here. There's my data. There's my claim. Mean weight is more than 20 pounds. More than 20 pounds. That looks like the mean is greater than 20 pounds. It looks like I've got the alternative there. So let me go ahead now, get a fresh sheet of paper. Everything's ready to go with our calculator for the most part. again, that is my initial claim. All right, now we're ready to find the p-value. And I'll compare it to 5%, and we'll see where it goes. All right, so now I've got data. My mean and the null hypothesis, and do note the little zero there if I didn't point it out already. I have my data in list 1. Frequency is 1. We've got a right tail test again. Now we'll go ahead and hit calculate and pick out the p-value. That's a big p-value, yeah. P-value is equal to 0.523 and change, 0.523. Let's see, so what do we have? Wow, we had a mean that was, wow, actually less than 20 pounds. So I really wasn't that far wrong with my gut, but anyway, I'll leave that go. So P equals 0.523. We compare that to, hold on, 0.523, 0.05. So this one is quite clearly greater than the level of significance, this p-value here. So it's fail to reject the null hypothesis. Now, that means that even though this guy here was my initial claim, this guy here was the actual outcome for the result. So, using the boilerplate language, add alpha equals 5%, data do not support mu greater than 20 pounds. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5 steps to stat test nirvana. So there we go. I'm almost out of time, and that actually does bring me to the end of my discussion in section 8.2 or 8.3, excuse me. Let me go ahead and stop my recording.